Let's go to the beach, let's go get away. That's what I've decided today. We're going to the beach, and it's a Monday mood because it is fraction time. I've been waiting for fractions for so long, you guys. Fractions are so awesome, and I bet you've been waiting for them too. And now they are finally here, and we're going to talk about halves and thirds and fourths today. And little Minion is really excited too because it's fraction time. And it is lesson 7. We have skipped lesson 6 and we've moved on to lesson 7. And today on Zern, I want to make sure that you have your student notes printed out so you can do the cutting and the rearranging and the working through Zern because that is so important today. You can do where you print out the student notes, or you can get your own piece of paper, draw your own square, put it in half, and have 2 different triangles that you make different shapes with. So even if you don't have a printer, you can create your own student notes. And I really want you to do that because it is important to do math today, not just sit there and watch and go, but actually to do the math. Today, we have a really quick mini lesson that I'm going to fly through and talk through because we're going to be introducing shapes today, but we're going to continue working on shapes and fractions this week. So let's get going. Let's first explore halves using pattern blocks. I've got cool, colorful pattern blocks for us to explore today. So if we start with this hexagon, it has 6 sides and 6 angles. What smaller polygon could we use to cover half of the hexagon? Well, I know that one trapezoid covers half the hexagon, but look, I can put another trapezoid on top to cover the whole hexagon. So how many trapezoids make a whole hexagon? That's right, 2 trapezoids make a whole hexagon. Now, are they equal shares? Yes, because there are 2 halves. There are 2 of the same size and the same shape that cover the whole. And so we would say that there are 2 halves in the hexagon. Now, let's look at this rhombus right here. A rhombus is like a parallelogram, but it has all the sides are the same exact length. So if we look at this rhombus, what smaller polygon could we use to cover half of the rhombus? See if you can visualize it in your head. See if you can visualize if there's 2 parts. Ooh, 1 equilateral triangle covers half the rhombus. And look, we can put another equilateral triangle on top of the rhombus to cover the whole. And these 2 equilateral triangles are the same size and the same shape. So how many equilateral triangles make a whole rhombus? 2. So are they equal shares? Yes, because they're the same size and the same shape. So they're equal shares. How many halves? 2 halves. We always say 2 halves because a whole is split into 2 halves. There wouldn't be 3 halves in a whole. There are 2 halves in a whole. Now let's try something different. We're going to use a trapezoid now. These are one of my favorite shapes. So trapezoid, can you cover the trapezoid with 3 smaller polygons? Let's see if I can visualize it. Well, yes. What shape can we use? We can use equilateral triangles, just like we did before. 1, 2, 3, and it fills up the whole trapezoid, okay? How many equal shares compose a whole trapezoid? Well, in this picture, 3 equal shares because we put on 3 equal shapes. So we can call these 3 equal shares or parts thirds. Can everybody say thirds? Say thirds, thirds, thirds. We can call 3 equal shares or parts thirds. Now, what happens if we leave one triangle on and cover the rest of the trapezoid with a rhombus? Are these halves? I have 2. I have 2 parts on there. Are they halves? Is it thirds then? No, because they are not equal parts. They are not the same shape. So we can't say that they're halves. We can't say that they are even thirds because they are 2 different size shapes. They are 2 different shapes. They are 2 different kinds of parts, and so they can't be halves or thirds or really anything because they're not equal. But can we cover a hexagon with 3 smaller polygons? Let's check it out. What shape can we use? 1, 2, 3. Oh, it did it. I put on 3 rhombuses and I covered up the whole hexagon. How many did it take? How many equal shares compose a whole hexagon? 3. What do we call these 3 equal shares? We call them thirds. We call them thirds because it's 1, 2, 3. 3 thirds. Now, can we make one large square that is created with equal parts? One large square. What shape can we use? What shape did we use to create one large square? We used 4 other smaller squares. Are all of the parts equal that we put on? Are they all the same shape and the same size? Yes, they are. So we can call 4 equal shares or parts fourths. Say fourths. So we had halves, then we have thirds, and then we have fourths. And all of the parts have to be equal for them to be called halves, thirds, or fourths, right? They all have to be equal shares, equal parts, equal shares to create one whole. We have halves, thirds, and fourths. Good job. We're going to stay cool and math on. And as we finish up today, you're going to go finish that Zern activity and complete the exit ticket. All you need to do on this exit ticket is just circle the shapes that show thirds and then fourths. And it might be 1 or it might be 2. So look carefully and make sure that you're circling all of the shapes that show thirds and all of the shapes that show fourths. And remember, every single part has to be equal. It has to be the same shape. It has to be the same side for it to be an equal share in halves, thirds, or fourths. Bye, guys.